Welcome to the deep dive. Today, we're heading back, way back, to late Cretaceous Brazil.
A time of giants.
Absolutely. And we're focusing on Austroposeidon magnificus. Quite the name, and apparently the biggest dinosaur found in Brazil so far.
That's the one. Our info comes mainly from the Wikipedia page, but it pieces together the key research.
Right. So our mission today, essentially, is to figure out what makes this giant so special, especially given we don't have a whole lot of fossils for it.
Exactly. Even fragments can tell a big story. We're looking at a snapshot of these huge South American titanosaurs near the end of their reign.
Okay, let's start with that name. Austroposeidon magnificus. It just sounds massive. Break it down for us.
It really does, doesn't it? Well, Austro is pretty straightforward Latin for southern, because, South America.
Gerson.
Then Poseidon. Greek, god of the sea, yes, but also earthquakes. And that's the connection here, hinting at the sheer size, the ground shaking as it walked.
Oh, I get it, like an earth shaker.
Precisely. And magnificus Latin again, meaning great, noble, elevated. It just hammers home the impressive scale.
So, magnificent southern earth shaker. I like it.
It fits, I think.
So when did this magnificent southern earth shaker first reveal itself?
The actual bones were found quite a long time ago, back in 1953.
53, wow.
Yeah, by the paleontologist Llewellyn Ivor Price. He found them along the Raposo Tavares Road in an outcrop of what's called the Presidente Prudente Formation.
Okay.
The specimen number, if you're interested, is MCT 1928-R. But here's the interesting part. It wasn't formally described and named until 2016.
Whoa, hold on. From 1953 to 2016, that's more than 60 years. Why such a long gap?
Well, it's not unheard of in paleontology. Sometimes fossils need extensive preparation, or they sit in collections waiting for someone with the right expertise, or, funding might be an issue. Lots of reasons.
And I heard something about the site itself.
Yeah, that's the unfortunate part. The original discovery spot, well, it's gone. Lost to urban development.
Well,
There was an attempt around 2010 to relocate it precisely, but no luck. The area had changed too much.
that's a real shame. A lost context.
It really is. It highlights how important site preservation and documentation are.
Definitely. So back to 1953. What did Price actually find? What bones are we talking about?
We don't have a full skeleton, sadly. What was found were parts of the vertebrae, the spine bones.
Okay.
Specifically, bits of the neck vertebrae, the cervicals, bits of the back vertebrae, the dorsals, and some sacral vertebrae from the hip area.
So fragments from different sections.
Right. Plus, a cervical rib, one of those thin bones coming off a neck vertebra, and one whole dorsal vertebra. Just one, but complete.
One complete vertebra from the back, and from that and the other pieces, they could estimate the size.
Exactly. By comparing these bones, especially that complete dorsal, to other titanosaurs where we have more material, they can make an estimate.
How big are we talking?
The estimate puts Austroposeidon at around 25 meters long. That's about 82 feet.
82 feet. Okay, that is seriously big. Like 2.5 school buses, maybe?
Roughly, yeah. It makes it the largest known dinosaur from Brazil, potentially tied with another one called Uberabatatin. These were truly colossal animals.
It's mind-boggling. How did these bones even survive? You mentioned the formation, but how did they get preserved?
Well, the type of rock they were found in offers a clue. It was a fine sandstone.
Okay.
The thinking is that it was likely preserved in what's called a crevasse splay deposit. Imagine a river breaking its bank, maybe during a flood, creating a small side channel that dumps a load of fine sediment onto the floodplain.
Right, like a sudden dump of mud or sand.
Exactly. If the carcass was there, it could get buried relatively quickly by this fine sediment, which helps protect the bones from decay and scavengers.
That makes sense. So we have these huge bones buried quickly. What makes them uniquely Austropoidon, though? You mentioned titanosaurs were diverse.
Ah, good question. That's where we get into autapomorphies.
Autapomorphies. Right, the unique identifying features.
Exactly. Think of them as the dinosaur's specific diagnostic traits, things you only see in its fossils and nowhere else. They're crucial for defining it as a separate species or genus.
So what are the bony fingerprints for Austroposeidon?
They're quite technical, mostly details in the vertebrae. For example, on the 13th neck vertebra.
Okay, specific one.
Yeah. It has these bony ridges, laminae, connecting different parts. Two of these, the centropost-sigapophyseal laminae, are described as columnar, just a specific shape.
Columnar ridges, got it.
Also on that same neck bone, another ridge towards the back, the rear centrodiapophyseal lamina actually splits into two prongs, like a little fork.
Huh. Interesting detail.
Then moving to the first back vertebra, the first dorsal, The ridges on the side, the front and back center diapophyseal laminae, have a specific curve downwards and outwards.
Okay.
And on that same bone, a bony process called the diapophysis, where the rib attachus stretches further down than usual, right to the top edge of the main vertebral body, the centrum. And one more, further back in the dorsal vertebrae, the front part of another ridge system, the spinopresiga-apophyseal laminae, is forked.
Wow. That's incredibly detailed. It sounds like you need a PhD in vertebra anatomy.
Huh. It definitely requires a keen eye for detail. And it's not just those individual things. The researchers also noted that the combination of various features seen in Austroposeidon's vertebrae is unique among titanosaurs.
So the whole package is distinct.
Precisely.
Okay, that's the external shape. But didn't they also look inside the bone? Something about a CT scan?
They did, yes. CT scanning fossils is amazing technology. It lets you see the internal structure without cutting the bone.
So what did they find inside Austroposeidon's vertebrae?
They found these alternating concentric rings. Rings of denser bone tissue and rings of something called camellate tissue.
Camellate, what's that?
It's basically spongy bone with lots of small internal air chambers or pockets. Think like a honeycomb structure inside the bone.
Okay, spongy bone. And these rings,
Yeah.
what do they mean?
The interpretation is that they might be growth rings, a bit like tree rings.
Seriously, so you could potentially count them to estimate age.
Well, it's not quite as simple as with trees because bone growth can be affected by lots of things. But yes, they strongly suggest patterns of growth, maybe annual cycles or periods of faster and slower growth. It gives clues about how long it lived or how fast it grew.
That's incredible insight from fossilized bone and this spongy camellate structure.
That's actually pretty typical for titanosaurs. It's thought to be a weight-saving adaptation. You need strong bones, but making them solid would be incredibly heavy for an 80-foot animal.
Right, hollowing them out with air pockets makes sense.
Exactly. They also noted a couple of things Austroposeidon didn't have. It lacked those extra interlocking joints between vertebrae called hyposphene-hypantrum articulations, which is also common in titanosaurs, actually. And unlike some other sauropods, its neck and back vertebrae didn't seem to have large air sacs or pluricles invading the sides of the centra.
So some weight saving, but maybe not as much air inside as some other groups.
Potentially, yeah. Or just structured differently.
Okay, so we're getting a clearer picture. Huge, unique vertebrae features, internal growth rings, spongy bone. Where does it fit in the big dinosaur family tree?
All right, classification. It's definitely a sauropod, one of the long-necked plant eaters.
Yep.
Within sauropods, it's a macronarian, then more specifically a titanosaur. And even more specific, within titanosaurs, it's placed in a group called Lithostrotia. The full hierarchy goes all the way from Eukaryota down to the species A. magnificus.
A lithostrosian titanosaur. And what about its closest cousins? Any idea who it hung out with, evolutionarily speaking?
That's where phylogenetic analysis comes in, trying to build that evolutionary tree based on shared features.
Right.
The original 2016 study suggested Austroposeidon was the closest relative, the sister taxon, to a group called Lonkosauria.
Lonkosauria, another impressive name.
It is, and later studies seem to support this. A 2019 analysis didn't really change things for Austroposeidon, and then a 2022 study explicitly placed it within Lonkosauria.
So it's likely a member of this Lonkosauria group. What kind of dinosaurs were they?
They seem to have been some of the real giants among the titanosaurs. Think Futloncosaurus from Argentina, another huge one.
Okay, so a family of supergiants?
Pretty much. There's even some tentative suggestion marked with CF, linking Alamosaurus from North America to this group, though that's less certain. But it paints a picture of Austroposeidon belonging to this lineage of exceptionally large titanosaurs, mainly known from South America.
Fascinating. So, pulling it all together, what's the big takeaway? Why is Austroposeidon important?
Well, first, its sheer size. Being Brazil's largest confirmed dinosaur alongside Uberabatitan is significant in itself. It tells us about the upper limits of dinosaur size on that continent during the late Cretaceous.
Right, it pushes the known boundaries.
And second, even though the material is limited, those unique vertebral features, the autapomorphes, give us vital clues about titanosaur diversity and evolution. Understanding how these different giants are related is a huge puzzle.
And the Lonkosauria connection helps piece that puzzle together.
Exactly. It suggests this particular group of massive titanosaurs was a key part of the South American fauna and helps us map out their relationships and perhaps even their distribution. Every fossil, no matter how fragmentary, adds a piece.
It really shows how much we can learn from, well, not that much bone, relatively speaking.
It's detective work on a geological timescale.
So, to sum up, Austroposeidon, Brazil's giant, defined by unique spinal features, internal bone structure hinting at growth, and a likely member of the supersized Loncosauria family.
You got it. And it just underscores how much more there is potentially out there to discover.
Yeah.
Our understanding is always being refined.
It really has been fascinating digging into this giant. It leaves you thinking, doesn't it? If we learned all this from just these fragments, imagine what other colossal forms might still be buried under Brazil or elsewhere.
Mm.
What discoveries are still waiting that could completely redraw our picture of dinosaur life just before the end. It's definitely something to ponder. Thanks for exploring the deep past with me today.